All right, let's look at number 14 in section 3.9. We're to find the equation of the tangent line to this function at x equal 1. This function involves the natural log function, so we do need to be familiar with the derivative of the natural log function, or the more generalized rule, right, or chain rule derivative with respect to x of the natural log of u would be 1 over u times the derivative of the inner function. Du dx, we could sometimes write that as u prime, right? Du dx is u prime times 1 over u, or just u prime over u. And that's what I'm going to use here because this is really natural log of u. So when I take the derivative, it's 1 over u, 17 minus 8x, and the derivative of 17 minus 8x is just negative 8. All right, the derivative of the inner function. So this is chain rule to find the derivative of this function. We need the derivative. Why? Because to find the equation of the tangent line, we need the slope, and the derivative, remember, gives us the slope of the function. I need to know what the slope is at x equal 1. And so when I plug in f prime of 1, replace 8 with 1, replace x with 1. 8 times 1 is 8, though. 17 minus 8 is 9. I get negative 8/9. That's my slope. Okay. And then the point of tangency, right? When you have the slope, we need a point. That's where it touches the graph at 1 comma f of 1. So if I plug 1 into the original function, I get 17 minus 8 here. So it's a natural log of 9. Now that's the exact value. You can approximate the natural log of 9 with your calculator if you wanted to, but that's not what they're going to ask for. They want symbolic notation, fractions where needed, right? If I take the natural log of 9, it's just a number, but about 2.197. Okay, but we're going to leave it in that form. So now when I go into my point slope form of my line, m is my slope, right? This is the value of m here. And that's negative 8/9. Y1 is the y coordinate here, which we evaluated to be natural log of 9. X1 is 1. So here's the equation. Now, notice 8/9 times x minus 1, negative 8/9 times the quantity x minus 1 is the same thing as negative 8 times the quantity x minus 1 over 9. In other words, I can just multiply x minus 1 over 1, multiply those two fractions together. And then to solve for y, I just add the natural log of 9. So we could write it this way. Typically, though, the way I've been doing it, right, distributing this negative 8/9 through, I get negative 8/9 x, negative times negative, positive 8/9. And then if I add the natural log of 9, I get this. These two expressions are identical. I think you're having trouble with achieve again, I think it may accept hopefully both of these, but either one is acceptable. Now, just make another comment, a couple things. Well, the natural log of 9 can be rewritten in different ways, and some of you I notice do some interesting things. For instance, natural log of 9 can be written as natural log of 3 squared is 9, right? And then by the property of logarithms, this 2 can come down in front, 2 times the natural log of 3. Could we replace natural log of 9 with 2 times the natural log of 3? Yes. Is it needed? No, not really. It doesn't help any, I don't think, in the expression. So, sometimes simplifications or doing certain things may seem helpful, but are not necessary a lot of times. And that's just part of the process of doing calculus. You're doing, 80% of what you're doing is algebra, geometry, trigonometry, working with logarithms and such, pre-calculus work, right? And so you're getting better at those skills, and that's important to be able to adequately express your answers and communicate what you're doing to others. Okay. This is the result, though, for this particular problem. Hopefully that makes sense. If not, certainly let me know. Hope this helps.